Welcome to all. Today's class will be a special type of class. See, as we go further in friction, we get lot of connected members. Two members are connected together. We will be considering motion of that one or friction at that time. Also, sometimes a block or rectangular block or a body will be connected to a rigid surface by a cable or wire or some rod. You will be asked to analyze the question. So at that time, what you require is connected member is in between, some connecting member will be there. It can be a rod or it can be a cable, etc. Don't bother about it now. So tensile force and compressive force in members. Remember, I will tell again and again now, tensile force symbol I will take T later. See, tensile force symbol I will take T. Compressive force symbol I will take C. In members, which will be reacting forces on the body to which this member is connected in engineering mechanics. Now, see, note, explanation will be restricted to application in engineering mechanics. So, I will tell how to decide the compression or tension in a member or how the reaction will come on the body to which it is connected. See, now make a note. I will restrict my explanation only for engineering mechanics because later in strength of materials, we will not call this as tensile force or compressive force. They are called axial forces. See, when you go to briefly strength of materials, a term called strength will come. Strength is capacity of the cross section to resist something called section forces. Section forces. Section forces. There are total 4 section forces are there. First one is axial force. Second one is shearing force. Shearing force. Third one is bending moment. Bending moment. Fourth one is torsional moment. Torsional or twisting moment. At that time, axial force, our symbol usually will be P. Shearing force will be V. Bending moment will be M. Torsion will be T. Remember, these 4 section forces are the basic fundamental. Your complete strength of materials deals with behavior or resistance or member strength to resist these 4 section forces. Actually, in the axial force later, this tension and compression will come. See, this tension or compression will come in section forces. See what I wrote here, tension force or compressive force, it will come in axial force. There, we will seriously discuss and very elaborately, maybe to explain tension and compression. See, internal force, internal resisting force, stresses, strains, deformation, everything will come there. Capacity of member to resist it. In engineering mechanics, we are not bothered about material property. See, so that we will study there. And it is very important. It is a section force where lot of concepts are there. For your information, when I discuss strength, when I go to strength of material, see, this section forces explanation itself will be more than 3-4 hours. Okay, there. So many concepts are there. All I will explain. And unfortunately, so many blunders are committed everywhere. See, when I tell blunders are committed, my purpose is not to insult them. People are not knowing. Unknowing, see, they are not knowing. They are ignorant. There are so many finer points. They create blunders. My purpose of highlighting that blunder is only to educate them. I will tell At least now onwards, don't make the blunder. Not to insult them. My purpose is not at all to insult. I want everybody to learn. So these all will be in strength of materials. Remember, it is this tension, force, what I told T here, compression C, both come under axial force. It is not by direction. Remember, of course, engineering mechanics, you will decide direction because we will not consider the force on both sides. We will consider contact point. At the contact point, it will be direction based. But when you take the member force, suction force, it is not direction based, it is nature based. These all we will discuss in strength of materials. So, right now, my explanation is only restricted to application in engineering mechanics. See, suppose somebody who will go through this class, when I explain tension and compression, he may comment or comment may come. What? So simply, that's all. There are a lot of concepts are there. He is not telling the internal force, nothing he is telling. I will tell them, we are in engineering mechanics. How much knowledge you require for engineering mechanics, that much I am telling here, that's all. There is no point in giving half knowledge. See, engineering mechanics, if I start explaining partially, it will become half knowledge. People will not understand. Therefore, no, I will explain only from engineering mechanics point of view. Therefore, I will tell them, if you are that much eager to know, you come to strength of materials, then comment. Then they will not comment. They will tell, if they are serious and what you can call is honest, then they will tell, yes, this is complete explanation given, including highlighting the blunders committed, that all highlighted, and remedy also I will give you. When somebody is committing a blunder, I will tell, this is wrong, you correct it this way. So therefore, remember now I am continuing this tension force symbol. I will take T, any symbol will do. Usually, if symbol is our choice, tension force T, compression force C, in members which will be, see, in members which in engineering mechanics, later mechanics, will become reaction forces on the body to which this member is connected. Suppose a body is connected to a support by a cable, it will be in tension. The tension in the cable will become reactive force for that body. That's all. I will explain that one. Same way compression. Okay, now this is some information only. See what all I told here, you never bother now. You used to wait for engineering mechanics to be over. Let me start strength of materials. That is where real structural knowledge will start. Okay. Now, some example I will write and explain. Now, first to understand tension. See, tension. Do one thing. Some statement I will dictate. You have to write. Consider a body. This is the body under consideration. Consider a body of weight W suspended by a cable. See, it can be cable or rope or wire, thick wire or string. So many words are there. Sometime examination they will give you what? Cable, most proper is cable, or some rope or wire or string. Remember, very, very important, this cable, rope or wire, all of them are flexible members. Very, very important. I am searching for a cable here. Plenty of cable. One minute. Some cable, I will get it now. I was searching for it, I got it now. See, the sketch is not neat actually. I write it neat. Okay, 1 minute. See here. I'll put later. See. This is some support. See. Don't worry. Some support here. Cable. Weight W. Consider a body of weight W. supported by a cable. See, I'll show you the support. See, where is it? Here. See correctly. See, I think you can see it now. See, support by a cable. This weight is W. See, this is cable. Some support is there. I am fixing here. See, this is the case. Now, what will happen? This body weight is acting down. See, I'll show it now one by one. See, this body weight will be acting down. Now, but if there is no cable, it will fall down. Now what will happen? Body weight will act down. So for equilibrium, this cable will be lifting the body up. See here. This cable will lift the body up. Then here, it will be like this. Okay, that is not required for you. This is tension in the cable, T. This is tension. Why arrow mark opposite? Later I will tell you. This is tension in cable. Tension force in cable. Force in cable. See here. Now, see, tension force in the cable, when you write only tension force in the cable, it will be, see, if you consider only cable, project here. If you consider only cable, if this is the cable, see, this is a cable, tension force in the cable will be always like this. Sometimes people will tell, sir, it looks like compression. No, it is the internal reacting force. Everything in strength of material. See, when you pull down here, it will lift up. Then this point, what will happen now? Again, see, when you apply down here, see here, see, this is reversed. What is this one? See, okay, see, here, it will pull it down, reaction comes up. By mistake, I put arrow mark. Okay, no problem. I can realize, see, here, see. Therefore, see, but we are interested only in this one. That all we are not bothered. Only this you are interested. At the contact surface, what happens? So, this is cable in compression. Cable in tension, not compression. Table in tension. This is the force T. Now, 1 minute. This is flexible member. So, you should know, in any question, when a cable is given, cable or wire or rope or string given, it should be in tension because, see here, it cannot take compression. See, where is it here? See, I can suspend by a cable. See, this can be a cable or wire or string or rope. When you apply load here, see, it will pull the cable this way. Cable will be in tension. Okay. Now, if I reverse and leave it now, what will happen? See, this is a flexible member. See, every flexible member can take only tension. See now, it cannot resist compression. See here, it will fold. You can even fold like this. See here. See, if you try to compress it, it will not take. See, it can take only tension. Therefore, remember, first of all, any flexible member can resist only tension. Only tension. So, in a question, if a cable is cable or wire or rope or string given, then it should be tension force. Okay. Now, this you don't bother. See, this all will come in strength of materials. Right now, don't bother. Now, see here. You consider, see now, I'll remove this one now. See, now, consider equilibrium, right here, equilibrium of the body. See here, body. When you take equilibrium of the body, see here, weight is acting down. For balancing, this tension force is acting like this, T. So, this is action. This is action. This is reaction. Reaction on the body from the cable, from cable. Reaction on the body from the cable. Or, remember, permanently, tension T is always act outwards. Act outwards. Outwards. When tension T, see, when considered as a reaction, on the body, will always act outwards or away from the body. Away from the body. This statement is sufficient for you. So remember this statement. Tension will always act away from, outward, or it will go away from the body. Remember this one. Engineering mechanics point of view sufficient. I do not want to waste further time telling so many things. See, I will give an example for you today. Okay, then. Now come to compression. Brief, see, I am telling, see, actually tension, compression, you are studying strength of materials. But engineering mechanics, when a cable given or rope given, you require that concept. Okay, now consider that compression force. See, compression force. I will solve two simple examples today also. Compression force. That is C. Our symbol is C. Okay. See now. For that, you consider, see right here, consider a body of weight W. Now, compression means the member should be rigid member. It can't be flexible. Okay, I will do one thing now. See, this is the body, a little smaller I put here, see. Or I will take a body with less, smaller size. See, this is the body considered. Body considered. For equilibrium, our problem is body considered. Weight W. Weight W. Imagine it is placed on a vertical member here. See, big member. See, big member. This is some member which is not, see, not flexible member. It should, see, some member which is 100% not flexible. Not flexible. Why? If it's a rigid or somewhat rigid. If it is flexible, it will not stand. See here. If you place a body at some member below, flexible, it will fold. See, it can't stand. Now, I'll give another example for you. See here. Consider a body. See. Once again, take a body. See, some object here. Place here. Now, over the body, you place a weight. See. Over this one, a small weight. See, place a weight. It is bigger. I put smaller weight. Okay, so that it will happily stand there. Okay, something. Don't worry. Okay, one ink bottle. Okay. Imagine some weight is there. See, this way. This is a member. See, over that one, some weight W is placed here. See, this way. Now, this weight is acting vertically down. It will try to push the body, this member, some member, down. So for equilibrium, this member will give upward reaction. Okay, that much sufficient for you. See, where's the cap? I lost the cap actually. The problem is if the pen cap is lost for a long time, ink will stop writing. So now, therefore, how is the action now is, see. If this is the member, see, this is the some member supporting the body. And this is the weight. See here, this weight will act down. This will push it down. This will give reaction like this. See, then finally it will come this way, some reaction here. Now, this is your compression C. This is what you require. See, contact point. So, the C is compression force in supporting member, which will be reaction on that body. This is your body considered. considered, which reaction on body considered. Body considered. Okay. Therefore, if I write only compression, see, it will be like this. Only compression is like this. This is compression. Or, remember, compression force, when considered as a reaction force, on the body will always, I told, tension force is always what? I told some word last time, forgot now. I told away, before away, what I told you? I forgot now what I told. The tension force will always act, I told, away. Before away, something else I told, a word. No, I forgot what. See, so many words are there. The tension force will act towards, okay, will be, see, that is away, this will be towards the member, towards the body. See here, when you consider the body here, the compression force is always towards the body. So it will be, last time I told, it is away from the body. I don't know what is the other word I used. Opposite word you have to use here. Forgot how I see. This, so many words are there. I don't by heart and come to the class. So if I remember, I can tell. Okay, this is acting towards. Last time tension, it is acting away from the body. Compression means it is acting towards the body when you consider as a reacting force. Okay, sufficient. Other word I don't know. Leave it. Now I'll give final conclusion for you, so that engineering mechanics, there are people who will comment, this is not the way to explain tension compression. I will tell them, I am explaining tension and compression required for engineering mechanics as a reaction force on the body to which that member is connected. For that, I am giving sufficient information. If you want more knowledge, come to strength of materials. I will show you the real power of that concept at that time. I told minimum 4-5 hours I will tell. Therefore, remember, conclusion, see, sufficient, conclusion. So, whenever a body, whenever we consider equilibrium of a body, to which a member is attached. Whenever we consider equilibrium of a body to which a member is attached, then that member will be either in tension or in compression. Okay. And that tension force or compression force in that connecting member, which can be a cable or a rope or some rod, anything, so many things. But if it is a cable or rope, it should be in tension. Then in that connecting member, then that tension force or compression force in that connecting member will be a reacting force on the body considered. It will be a reacting force on the body considered. And remember, I will tell lastly, from engineering mechanics point of view, if tension, it will act away from the body, away from the body, and if compression, it will act towards the body, see, towards the body. Okay, now I will do one thing now. See, just to understand everything once again briefly, you study from engineering mechanics. See, actually I got difficulty of explaining because I know so many things about this one. In the notes later, in strength of materials, this tension compression notes, number of pages will be more than 300, 400. Then that much I am knowing, I have to condense myself to limitation. So therefore, see here now. Suppose there is a body, see here. This is body under consideration. Okay, then see here. If a force is acting this way, it is tension. If a force is acting this way, it is compression. Or if a force is acting this way, see, it is tension. See, compression means, tension means, right here, once again, tension means away from the body. I cannot explain further. And compression means towards the body, under consideration, both as reaction forces. So therefore, if a force is acting this way, it is compression. See, again, if a force is acting this way, it is compression. If a force is acting this way, it is tension. If a force is acting this way, see, it is compression. If a force is acting this way, see, it is tension. I think clear. Anyway, randomly I am asking. Always, and remember, body, it will both act as reactive forces at the contact point. See, at the contact point with the body. Okay. Make a note. In the class, he explained in simplest possible way. Because in engineering mechanics, we cannot go to strength of materials. Therefore, if later someone who will see my strength of materials class, he will tell, this much is he told, long back something else he told. I will tell, long back I told from engineering mechanics point of view. That's all required there. Furthermore is not required. So more knowledge you get in strength of materials. Now, I'll give you two examples for you so that you understand correctly tension compression. See, there is no question number now. Last time, question number 13. Correct, I remember. Next is question number 14. That is in the next class, not today's class. Today's class is exclusively for concept of tension and compression. See here. Example 1. Two simple examples. Example 1. Okay, example 1A. See, first I'll give here. First I'll give examples for tension. For tension force. I'll put number 1. Two examples I'll give you, but I'll write the example to save the time. Again, otherwise, time consuming. See, two examples I'll give you. First, examples for tension force. Okay, start. Two questions. One question, second question. Two examples. Now, be careful. These are not on friction. Friction will come next class. Okay, see. Question I will dictate. You write it to understand. Once today's class is over, from next class onwards, if anybody gets doubt, sir, why you mark tension this way, why you mark compression this way, I will tell, leave my class, don't come to my class. See, question. A body weighing, I'll forget later, a body weighing 20 kilonewton, I'll forget it later, I'll make a note. A body weighing 20 kilonewton is resting on a smooth surface. See, smooth surface here, horizontal surface. And it is subjected to a force of 6 kilonewton to right side, as shown in the figure. See, if you place a body on a very smooth surface, when you apply force, it will move. Okay, now, next question. It is placed on a smooth surface and subjected to a force of 6 kilonewton as shown here. Then, next sentence. See, capital letter. To prevent the body from moving, a cable is attached on the other side. See here, as shown. A cable is attached on the other side, as shown. Question is, find tension in the cable. That's all question. Find tension in the cable. That's all question. Okay. Second question, see, dictated. A body weighing, that is 20 kilonewton, say, a body weighing 60 kilonewton. Okay, I'll remember it. 60 kilonewton is placed on a smooth surface, and an inclined force of 20 kilonewton is applied on one side, left side, see, this way, 20 kilonewton at 25 degree with horizontal. Oh, the sketch is, okay, little, okay, no, okay. And, right, to, see what will happen now? Body will move to left side because by no friction now, but, and to prevent the moving of the body, a cable is attached on the right side as shown in figure. See, as shown in figure, here cable is horizontal, here cable is inclined. Okay, here given force horizontal, given force inclined. Okay, sufficient. Here also question is, find the tension in the cable. Okay, solution, see here now. Consider, see, directly consider, before that make a note, very important note, I will not tell. For both questions, surface is smooth, very, very smooth. Therefore, no friction. There is no friction today. Some will tell, sir, you are in the friction chapter. Yes, I will go to friction next class. This is to understand tension compression. No friction. Therefore, only what? Normal reaction. Only normal reaction. Only normal reaction R. That's all. Friction will not be there. Make this note, right? Consider equilibrium of the body. Consider equilibrium of the body. See. Here also consider equilibrium of the body. And simultaneously solve to understand correctly of the body. See, sketch only body. See here. Next one thing, one statement you are right. Let, see, R be normal reaction at the contact surface, you write, and let T be tension in the cable. Tension in cable. See, anybody can make out. When you pull this way, this cable will be in tension. Here also. When you pull this way, cable in tension. Here also, right here. Let R be normal reaction on the body from the surface. Right here. Normal reaction on the body from the surface. And let T be tension in the cable. Okay. Okay, now consider free body of the block. See here. This is the free body of the block. Weight is acting down. How much weight acting down? 20 kilonewton I told. 20 kilonewton. Here also, see, weight is acting down. Space problem is there. Let's decide right here. See, right here. Space required. Okay. Here also, for the block, 20 kilonewton weight is acting down. This is action. 20 kilonewton. And here, one right side force of 6 kilonewton. Action. Given in the question. Here, one inclined force of how much? 20 kilonewton with horizontal, it is making angle of 25 degrees. Okay, little bigger right here so that I can show it clearly. Okay, unmade. Okay, now correct. How much is 20 kilonewton force with horizontal, it is making angle of 25 degrees. Okay. Then these are the action. Now, see, from the surface, there will be a normal reaction. Normal reaction is R. Normal reaction. Here, red color I am not writing. Normal reaction R. Then, this is cable. This body is moving this way. Tension. See, I told you, already told you, at this contact point, tension in the cable. Close your eyes. Tension will always act away from the body. See, when you consider the body, that's all you require. Tension means acting outward. Sorry, I told earlier. See, tension is outward, compression is inward. Okay, now clear? See, I forgot that word. I told tension means outward, compression means inward, or tension means away from the body, compression towards the body. Okay, here, this contact point, tension is inclined. See, tension T, away, and angle is, see, we want the angle, they told with the vertical 60, but we want this angle, that is 30 degrees. Okay. Why 30, I should not tell. If I explain why 30, it will be insulting for people. Okay, now, before you go further, here, see, note, pencil, left component, up component, right component, up component. Here, no resolution. Okay, now, here, see, equilibrium conditions are sigma fx0 and sigma fy0. I will do one thing now. Sigma fy0, actually waste of time. Okay, I write here. Where right now? Okay. See, sigma fy0. Okay, what you get? Plus r upward positive. Plus r minus 20 equal to 0. Therefore, your r equal to 20 kilonewton. And sigma fx0, right side positive, see here, it is right side positive, minus t, see here, minus t plus 6 equal to 0. Therefore, your tension in the cable T equal to plus 6 kilonewton over. We got the answer. We got the answer. Sufficient. Okay, here. Sigma Fy0. Take upward positive. See. Plus R minus 20. Then plus 20 sine 25. 20 sine 25. Then plus T sine 30. Sine 30. Remember, this is cos, this is sine. This is cos, this is sine. T sine 30 equal to 0. You call equation number 1. Don't simplify, not required. Okay, then sigma fx equal to 0. Take right side positive. What you get? See, plus T cos 30 minus 20 cos 25 equal to 0. Oh, we got the value of T. Yes, you can write T we got. What about normal reaction? Who wants it? We do not want. We do not want normal. Today's class, we want to find only T. That's all. Tension in the cable in kilonewton. Get the answer. That's all. Okay. Now, once you get T, if you substitute here, remember, this time friction is not there. Friction is there means concept is changing. That's why today's example is only to explain how to consider that compression tension. Okay, it will come 20 into cos 25 divided by cos 30. 20.93, 20 point, the answer will come plus 20 point, I forgot the answer, 20.930 kilonewton, 933 kilonewton over. Make a note here. Somebody will ask, what about reaction arc? No, the question is only to find tension, that's all. Remember now, I'll do one thing. Okay, now remember, now onwards, in any question, if a body is connected to a cable or wire or rope, it should be in tension. You mark the tension as T. If they give some other symbol, they can give P symbol, okay. Then tension you mark acting what? Outward or away from the body. Remember, as a reaction force. It is a reaction force on the body. So, I am concluding now, tension, when you mark tension as a reaction force on the body considered, mark it outward or away from the point, away from the body. Okay, over. Now I will give examples for compression force. What I am doing is I am changing the question. Compression force, compression force. Okay, I will do one thing now. Okay, write new question. New value will be new value. Now, two examples for compression. See, example 1, question 1. Dictated. A body weighing 600 Newton, because I will remember it, 600 Newton is placed on a smooth surface and a force of, say, some 350 kilonewton is applied as shown in the figure. Okay, so somebody is applying, last time, see, you are applying tension. Now, no, this way. Last time the force was trying to move right side. Now it is trying to move left side, 350 Newton, smooth surface. Then question is, find the compression, a 350 Newton is applied. Now, to full stop, and to prevent the body from moving, a rod is attached on the other side. See, some rod, this way. Some rod is attached. Now remember, now cable will not do. If you put a cable here, when you apply the force here, you know what will happen. If you apply force there, see, the cable will fold. Now it should be a rod. See, cable will not do now. Anyway, question given, rod. This is a rod. Okay. Find compression force in the rod. Okay. Question 2, dictated. A body weighing 500 Newton is placed on a smooth surface and an inclined force of 300 Newton is applied from one side. See, as shown at 35 degrees. Now, to prevent the block from moving, a rod is connected to the body, inclined rod, a rod connected to the body placed at inclination of 40 degree with horizontal, or as shown in the figure, a rod is connected. Okay, some rod. See, this question, see, the rod is here. This question, the rod is somewhere here, inclined. Okay, no problem. Question is, find the compression in the rod. Okay, solve it. Note, again both question, no friction. Why no friction? Right, because it is given in the question, smooth surface, only normal reaction. Right. Let R be normal reaction. Here also, let R be normal reaction. Now you should know it. See, if last time the body was moving this way, it is moving away from this member. when the body tends to move away from the connecting member will be in tension. This also make a note. And when the body moves towards the connecting member, then member will be in compression. So I will explain once again last. Okay, so let C be compression force in the rod. Let C be compression in the rod. Okay. Consider equilibrium of the body. See here, equilibrium of the body. A weight of how much to 600 Newton given in the question. There is a normal reaction here and a force of how much? 350 Newton. See, the 350 Newton will move towards the rod. So rod will be in compression. I will tell you once again last at the end. See, this is the compression in the rod. I told you tension means going away, outward. Compression is inward or acting towards the body. 1000 times told. Okay, now start. Sigma fx 0. Now waste of time. Sigma fy 0. You get plus r upward positive plus r minus 600 equal to 0. Therefore, r equal to 600 Newton. Then sigma fx 0 right side positive. What do you get? Plus c, see, right side positive, plus c minus 350 equal to 0. Therefore, compression in the rod C equal to 350 Newton over. Last time kilonewton, this time Newton. Here see. Right, equilibrium. Show equilibrium. Weight acting down. How much weight acting down? For 500 Newton. Normal reaction R. Then a force of how much here? This force. See, this force is 300 Newton, making an angle of how much? 35 degrees. Now be careful here. At the same contact point, see, this is the rod. I told rod will be in compression when you try to push this way. Compression, see, therefore be careful. It is compression, see. Compression. Okay. Angle is 40 degrees. Now take pencil. If I explain further, it will be insulting to everybody. See, right side down, cos sine. Left side cos, vertically down sine. This if you are not knowing, don't continue my class. Okay. Sigma fx 0, take right side positive. Sorry, sigma fy 0 first. Okay. Sigma fy 0, take upward positive. Plus r minus 500, then minus 300 sine 35, then minus compression force C into sine 40. Compression force C into sine 40 equal to 0. Equation 1. That is not required for us. Sigma fx 0. But next time required because friction also is there. See, next time friction will be there. Okay, then normal reaction required. So if you take right side positive, what happens now? See, plus 300 cos 35 plus 300 cos 35 minus that C cos 40, C into cos 40 equal to 0. Therefore, your C will come answer right in Newton. Normal reaction not required. 300 into cos 35 divided by cos 40. 320.798 kilonewton. 78 Newton. Okay, over. Now, I am concluding the class. See, I am telling last title. Before I conclude the class, see, before I conclude the class now, I will tell the final verdict for you. Remember for engineering mechanics in future. See, if the body moves or tends to move away from a supporting member, that can be cable or rod, anything. It can be a cable or rod, cable or wire or string or rope, anything, or rod. See, rod can take tension. If it moves away from the rod, then that supporting member, if you move away, supporting member will be in tension. Say T. And that tensile force will be a reacting force on the body, considered on the body, and that T will act outward or away from the body. Okay, now onward, see, if a member moves away, what? Away from the connecting member will be in tension. Then, see, at common sense, see, if you move away from a connecting member, tension. If you move towards a connecting member, compression. Okay. And whenever tension, it's a reaction force on the body. Tension force is away or either will be outward or away. Okay. And once again, if a body moves or tends to move towards a supporting member, now that member is in compression, now cable is not possible. It should be a rod or some rigid member. It can't be cable, rigid. Then that supporting member will be in compression. Both you are right, compression. Say C. See, if a body tends to move towards the member, it will compress it. See, and that compressive force will be a reacting force on the body, and compression will act not outward, inward, or towards the body. Okay, over. Now, I am stopping now. In future, I will not explain. See, this way, tension. This way, compression. 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 Sufficient. Furthermore, I can't tell. See, acting away from the body. You should see the body here. Acting away, tension. Towards compression. Away, tension. Towards compression. Away, tension. Towards compression. Away, tension. Sufficient. Go through it. Next class, I will start connecting body questions. Thank you. We'll meet next time.